Okay, conditions for rhombuses, rectangles, and squares, section 6.5. So just like sections 2 and 3 went together, 4 and 5 go together as well. So in 6.4, we learned the different properties for rhombuses, rectangles, and squares. Then in 6.5, we're going to say if something is a rhombus, a rectangle, or a square, what must be true. So, Theorem 6.16. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So again, this is kind of like the converse of what we did in the last. So if I have a parallelogram and its diagonals are perpendicular, then you can say it's a rhombus. 6.17. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So again, if I have a parallelogram and its diagonal bisects an angle, then I can say, yep, that's a rhombus. And the last one we're going to look at, I know this is a very, very quick video, I'm sure you're happy, is that if the diagonals of a parallelogram are congruent, so again, if AC is congruent to BD, then we have a rectangle. That didn't look very much like a rectangle, did it? So let's back it up. Sorry, guys. So in order for these diagonals to be congruent, we have to have a rectangle. Okay. So two quick examples of problems. So if I give you this picture and I give you some side lengths, 3x plus 9 and 8x minus 1, what would have to be true, or what would be a value of x that would guarantee that this shape is a rhombus? So if this is a rhombus, these sides have to be equal. So I end up with 5x equals 10, x equals 2. So for the value of x equals 2, this parallelogram is a rhombus. If I give you this picture, and I say that this segment is 3x minus 5, and this segment is x plus 1, and I say what value of x would make this a rectangle? Again, in order for this to be a rectangle, the diagonals have to be equal. So 2x equals 6, x equals 3. So again, pretty cut and dry. You saw this in section 6.2 and 6.3 that went hand in hand. Same thing here with 6.4 and 6.5. And that is it.